Slope-intercept form is one of the most common forms of an equation because it's easy to use. So in this form of an equation, the m represents slope, and the b represents the y-intercept, meaning the point at which the line hits the y-axis. So when I go to graph an equation like this, the y-intercept is the starting point, the beginning. The b stands for beginning. So you begin here, right? You say, oh, this is a -3. So you go on the y-axis to -3 and you start your graph there. And then from that point, you use slope, you use your rise over run to decide where your second point is. Another way we'll see this is with real life. When you go to write a real life equation in this form, remember that slope is our rate of change. So what's changing in this real life situation? Is it getting larger, a positive number? Is it getting smaller, a negative number? And this, just kind of like when you graph, this is where we begin, it's the starting point. This is whatever the starting point is. So if you have some money and then you're spending money, right, the starting point would be how much money you start with, and then the rate of change is how fast you're spending it. Are you spending it on $2 bags of chips? Well, then the rate of change is -2. You lose $2 each time. So that's the slope-intercept form. Now, sometimes we don't have slope-intercept form. We have what's called standard form. And a way to graph that is by using intercepts. And these are intercepts. This is the y-intercept. It's where the line intersects the y-axis, right? Here's your graph. Here's the y-axis, and here's where they meet. And what's interesting about the y-intercept is that the y-intercept has an x-coordinate of 0, and then a y-coordinate of something else, right? So, for example, this point could be 0, 7, or it could be 0, 5. It just depends on the scale. But this is the x-axis, and here's -1 and 1, but this is 0. So anything on the y-axis has an x-coordinate of 0. The x-intercept is the opposite. In the x-intercept, it has some x-coordinate, and the y-coordinate is always 0. Why is this important to know? Well, if I'm looking for the y-intercept, what I can do is I can, in a particular equation, and I'm looking for the y-intercept, what I can do is plug in 0 for x, and then solve for y. And if I'm looking for the x-intercept, then I can plug in 0 for y and solve for x. Okay, so understanding the way this looks on a graph helps you to figure it out in an equation. Last box. Sometimes we have inequalities with two variables, like y equals, not equals, sorry. Y is less than 2x minus 1, something like that. Right? There's two variables here, y and an x. And when we graph this, you graph this just using slope-intercept form. That's how you figure out where the line goes. But then you have to ask yourself two questions. Is the line dotted or solid? And it's dotted if you have a less than or a greater than symbol with no line underneath. And it's solid if you have greater than or equal to, or less than or equal to, right? Those are solid. The next question you ask yourself is, which way do I shade? So what you do is you plug in 0, 0, and this is 0 for the x and 0 for the y. And so, for example, that would look like here, 0 is less than 2 times 0 minus 1. And then that would be 0, right? This is 2 times 0, 0. 0 is less than -1. And then you decide, is that true or false? 0 is less than -1. Well, in this case, it's false. 0 isn't less than a negative number. But if it's true, you shade towards 0, 0. Right? You say, oh, that's a solution? Well, I want to shade it. So, for example, if this is your line, and I said, oh, 0, 0, that's true, that is a solution, I would shade this side of my line because I want to make sure, well, 0, 0 is a solution. So that means all these points around it are also solutions, and I want to shade that side of the graph. But if it's false, then you don't want to shade that, and you shade away from 0, 0. So again, if this was your line, and you said, well, 0, 0 is not a solution, I don't want to shade that, well, then you have to shade the other side.